Hi, everyone. Can you hear me?
Yes, we can.
Okay, I'm going to share my presentation. So welcome, everyone. Today, we'll explore. Oh, I'm Narusha Isaacs. I work for Bricks and Idea, and I was also part of creating resources for the data analytics training course. Today, we'll focus on statistical analysis. So this is just a broad overview of what I'll be presenting. A bit of Numpy, Pandas, Scipy, stats models. So why Python itself is so important? It's one of the most powerful scientific computing and used in scientific computing and data analysis. Python has also become incredibly popular because it's open source, which just means it's freely available and consistently improved by a huge community. It's versatile and integrates well with many libraries, making it ideal for everything from simple data cleaning to complex machine learning. Hence, many people use it within their various fields. We'll focus on these four tools. So the first would be Pandas, which is mainly used for data manipulation. Numpy is used for numerical computing, Scipy for advanced statistics, and Statsmodel for modeling statistical analysis. These tools work well together seamlessly for analysis and data reduction, so it works really efficiently. With other tools, of course, within Python, but we'll just be focusing on these four for now. So specifically, let's start with NumPy. So think of NumPy as a foundation to scientific Python. It provides us with powerful data structures called arrays, which is lists, but much faster and more efficient, especially for large number sets. NumPy allows us to perform complex mathematical operations much quicker, such as matrix multiplication, generating large random data sets. There's many other libraries, which I said earlier, such as Pandas and Scipy, which are built on top of the NumPy because of its speed and reliability. If you work with large data sets and need to do any heavy math, NumPy is one of the essential packages to use. Then we have Pandas, which is used for data manipulation. It's built on NumPy, but designed specifically to work with data structures such as tables, spreadsheets, and how to manipulate these data. We'll show you a bit later. Pandas introduces you to data frames, which is basically a two-dimensional table that has rows and columns. With Pandas, you can easily load data from many sources, clean them, handle missing data, duplicate values, filter through the data, to focus on what is most important and what you want to focus on in a specific data frame. You can transform by adding new columns, aggregating information, and just manipulating the overall data that you have. And since data cleaning and manipulation often takes up majority of a data scientist's time, Pandas is an indispensable tool and something that many astronomers and people that use data science use on a daily basis. Then we have Scipy, which is scientific computing, also built on Numpy and adds a vast collection of scientific algorithms within the Scipy package. It's especially powerful for statistics, optimization, signal processing, solving differential equations. So it has built-in many tools that you'd need. So in statistics, Scipy provides functions for hypothesis testing, probability distribution, descriptive statistics. This means you can test if there's a difference between groups, if you can model different data distributions, and much, much more. Scipy helps bridge the gap between raw data and meaningful scientific conclusions because you can use all the integrated tools within Scipy to process your data. Then we have Statsmodeling, which is a function that many people use to statistically model data. It specializes in building and evaluating statistical models. It lets us perform regression analysis, hypothesis testing, diagnostics checks. For example, if you want to understand how one variable influences another, like in astronomy, how a star's distance affects its brightness, Statsmodel would help us quantify this relationship and assess its significance. It provides detailed outputs, including coefficients, p-value, confidence intervals, which is crucial to interpret scientific results. I'll show you more within the Jupyter notebooks after the presentation. Then we have the workflow integration, which is one of the biggest strengths of these libraries. Okay. Anyway. Is it possible to mute someone? Okay, anyways. So this is one of the biggest strengths of these libraries is how well they work together. A typical data analysis workflow might start by loading and cleaning data with Pandas, performing numerical operations with Numpy, conducting statistical tests with Scipy, and then finally building a predictive model with Statsmodel. This integration means that you can handle your entire data analysis pipeline within a consistent Python environment, reducing errors and making your work reproducible and easy to share. That being said, besides the ones that's mentioned here, there's many, many other tools within Python, and that's why Python's used more often than other coding languages. It's just that the end-to-end analysis and the ecosystem of Python works really well because you can switch between different tools within the same notebook. Then we have some real-world applications. So these tools are widely used across many fields. I'll just touch on a few, specifically astronomy, which we use in research for cleaning data. Pandas is used for cleaning catalog data. In astronomy, we have lots of catalogs that we work with. Scipy is used to test if different groups of stars maybe have distinct properties. And then Statsmodel basically models relationship between brightness of stars, distances, and various other properties, depending on what your data frame or database has. So similarly, in biology, Pandas helps to manage their data. Scipy can perform statistical testing on gene expressions, and Statsmodel builds models to predict outcomes within various genetically modified applications. And then in finance, coding is used quite often. Most of the time, it's to use the time series model, which is also found in Statsmodel, to forecast stock prices and predict the stock trends. These are just examples of how versatile and essential these tools can be. There's many more real-world applications for Python besides inner research. Then, in a conclusion, because I'm not going to spend much time on the slideshow and more on the actual Python codes in the notebooks that you have. So in summary, Python scientific ecosystem, mainly what we're focusing on today, Numpy, Pandas, and Scipy Statsmodel, is very powerful and flexible and can be integrated environment for data analysis. Whether you're cleaning data, performing statistical tests, or building predictive models, these tools are extremely powerful to focus on science rather than just programming. And like I said, there's many other packages that you'll learn about, and hopefully if you take some of these information further beyond this course, you'll find that there are many, many more tools that have been developed throughout the community for your use. So thank you, and I'll be happy to take any questions before I move to the Python notebooks.
Narusha, there
Yes.
is a question. There's a hand up in the room and a question on the chat. So I think with the question on the chat, excuse me if I was wrong here, but the question on the chat perhaps was first, how to do hypothesis testing. And then after that, we'll go to the room, Alvu, Ray. So first in the chat, how to do hypothesis testing.
So that's something that will be covered in the notebooks as well. So, I don't know how I can.
Yeah, I think Lebo's online. He'll help mute, but if everyone in the room could help mute themselves as well when they come on. Okay, and then Alvu, maybe if you could, Rabin Nasir, if you could maybe unmute yourself and speak out.
Yes, thank you. Thank you, Sally. Just would like to ask Narusha about the a particular for example, because I understand you're working on the astronomy field, and
Yes.
yes, I'm particularly interested in knowing, like, if I'm new at Python and then maybe I learned something about Python years ago, but not really into programming, and am I gonna be able to like get up to it without so much a problem if I'm using like an AI tool to help me um, with the for example in photometry in astronomy.
So most of the time, so the Jupyter notebooks that we have set has lots of comments with instructions and extra additional help. You're more than welcome to send extra questions in the Slack channel and we can help you there. AI can be very helpful. You just have to be very wary that you might get some answer that's not all that truthful. So just check where it comes from. Something that you can do is ask AI to give you references and then go check up on the references and see what that says. If it maybe directs you to a journal paper or article, that's a bit just a way to verify what AI is telling you is correct. But you are welcome to send any messages in the Slack channel, and we can help you through that.
Thank you so much, Narisha.
Pleasure.
Okay, we've got a question from Anubab Dutta. What library can be used for simulating space-time geometries?
I have never worked with space-time geometries, but let me just think about it and then I can get back to you. If anyone else has an answer for that, you're more than welcome to answer.
And also maybe you could also ask that question in the Slack channel and we'll see what we can come up with as well there. Thank you.
There is something called Einstein Pi. I haven't used it, but I know someone that used it way back, and it does use space-time, something along those space-time matrices and things like that. So you could check that up. But yeah, suggest it in the comment in the Slack channel, and everyone can contribute to that.
Someone has replied, you can use Sage Maths. So Sage
Cool.
Maths. So that's cool. Okay, another question. Let's see. How many data points will be crucial for the stats model to create a reliable predictive model?
So it all depends on what you're trying to model. But like a basic rule of thumb would be at least 10 observations, because 10 to 15 maybe per predictable variable. And then moving forward, there will be a machine learning part in this where they'll tell you how to break up your data for testing and then training. And then so that all helps with the predictive model. So you first have to train your modeling to predict what you want and then test it with a certain amount of data.
Okay. And then we just have a question from Madhu. How can we use Pandas for making interactive data frames for big data analysis?
Okay, so Pandas itself is extremely useful because you can interact with your data. Let me just see what they said. Interactive, okay. Yeah, so you can add columns, you can remove columns, you can replace data sets. You can figure out if there's missing information and then try to predict what the missing information would be. So you're saying how can it use for big data analysis? It's very useful because you can analyze different columns at a time. So you could call a specific column from a data frame and work with that alone, or 3 columns at a time. You don't have to work with the whole data set all at once because that makes it a bit easier. But while you're busy working through the notebook, there is going to be a data set that you're going to be working with that's quite large with multiple columns and properties for stars. So that will help you understand how to work with these data frames.
And then just we've got a question from Rado Das. Could you suggest any material which might help me with learning optimal estimation and nested sampling methods? You can see the question second last one so far.
I can send you I'll add some links on the Slack channel. Yeah, so there is lots out there, especially within Python. So just post the question in the Slack channel and then I can add some links there.
And just a note on that to everyone in the room, there is a new channel called Week 2 Statistical Analysis if you have questions specific to this week's material. And then there's just there's a question from Jatin. Can I use Numpy to make various arrays and then use Pandas to arrange them in table?
So yeah, like I said earlier, it's very interactive between the two. So definitely you can use both at the same time. Once you've created those arrays, you can just use the data frame and create whatever size table you want to create and just save them there. You can save it as a CSV folder. So yeah, I can send a link on how to do that. I'm not sure if it's in the notebooks we've sent, but it is possible.
Okay, that's it from the questions that I can see. Are there any other questions in the room or online? Of course, please continue to ask them here and on the Slack, and we'll get to them.
Okay, so I'll just show you this week's different Jupyter notebooks, and then we can take it from there. Okay, so in week 2, so I think you all have access to this now. In week 2, you will have the data. So this is the data I was referring to. It's a CSV file. It's just a table with data set that comes from Gaia, and it has various properties. These specific Jupyter notebooks use this data. So the first one is just a brief introduction to Numpy. You can run this on your own time. I just want to show you what there is. So this just uses random data to show you how to use it, converts the data that you've created up here to an array. But yeah, this is just a basic how to use Numpy. And then this is basic how to use Pandas. And then the next one is specifically statistics. So this is also just basic Pandas, data frames, how it works. This is how the data frame usually looks, the various columns and rows. So if you were to create something in Numpy that had these details, you can just save it as a data frame. So if it looked like this, then you could save it to a data frame. That was one of the questions. And if you just go through this, if you have any questions, like I said, you can post it in Slack or on the chat if you have already gone through it. Then specifically this week is about statistics. And this notebook has data cleaning, filtering, and then just basic statistics with the Gaia data. This gives you a brief overview of what the Gaia data is. You can just read up on that. The key terms that would be using throughout this is data frames, which is just, like I said, a table spreadsheet. Rows and columns. Nans is just missing data, so there won't be a value. 0 is not considered a missing data. 0 is just a value. So a nan would mean that there is no data in that specific cell. Then we'll be filtering, which just means you're choosing the data that you want to work with, which I'll show further down. Vectorized, which is just an operation that helps do the calculations a bit faster. Basic statistics, I don't think I need to explain this, but the mean, mode, median, standard deviation, that is also something that would be used further down. Correlation, just checking how two variables relate to each other. And then plotting. So there'll be a bit of plotting, but next week is more visualization and plotting and how to use it. This week is just more statistics. So I think by now everyone knows the shift enter to run each cell. And then this is how we import data. Import the libraries. So these are the libraries that is going to be used in this notebook. So PD would now stand for Pandas. NP would stand for Numpy. Scipy would be Stats. Or you can say SP, or you can name this anything you want, as long as you remember what it's called, because you'll need it throughout the notebook. So make these as simple and easy to follow. And then Statsmodel, which would just be used SM. So firstly, we importing this data, loading this data, which was in this data file. So that's why it says data Gaia. So it's in this data file folder here. So you're referring to that specific folder. And then this is just printing what is in that data file, which is the source ID, array and deck, which is just the positioning, and various other properties of the specific stars. Data cleaning. So you're just removing problematic values. Like I said earlier, the missing values is called NaN values. And then negative and zero parallax, because distance can't be negative. So this specific cell does the cleaning, removing of this data. So they say rows after cleaning is 12,366. That means they removed all the rows that had missing data or negative data. Then we have something called data filtering, which focuses on bright and nearby stars. So by saying that, you need to actually know what it means to have a bright or nearby star. So here you can see that a bright star would have a magnitude, a G magnitude of less than a certain value, which here is less than 5. The parallax means how close it is to us. So that needs to be greater than 2. So this is what we call it. You can call it anything you want. DF is the data set, the data frame that we brought in up here, which was the Gaia data. And then this is calling that specific column, and that's calling the parallax column. And then N just means you're taking, it must meet this requirement and this requirement to be filtered into the filtered DF, which is filtered data frame. So now we only have 41 left that meet these requirements. Calculating. So now they want to calculate a new column. So taking this now data frame, what they want us to do is add a distance column, but in parsecs. So you have to do a calculation to convert the parallax value into parsec value, which is just a distance measurement. And in order to do it, you have to divide you'd have to take 1,000 divided by the parallax value in order to get the distance in parsecs. And then we add this new column. We called it distance parsec. So this is the name you giving the column. So it will be added to the end. You gave that as the title name. You could put parsec full, you could name it whatever you want to, but that would add this title here. And then all the values that is calculated from using the parallax value over here would now be in this last column. So that's how you add a column to a data frame. So that's just how to work with data frames and pandas, and also just how to manipulate your data and remove filtering out any missing data and choosing the ones that's nearby and the brightest. After this is just some statistical analysis and how to use that. So the first one would give you the mean magnitude, and that just takes the magnitude column, and then dot mean would mean that it calculates the mean or the average for that entire column. This is going to give you the median parallax, which you just type the column name dot median, and then it will give you the median value down here. And then standard deviation is STD, which just, so that's the basic statistics summary. Something that is often used is correlation, how two things correlate to each other or related to each other. So you call these columns and then you ask how it's correlated. These values tell you how they are correlated with each other. So parallax with parallax obviously is going to give you one whole because it's the exact same data. The same year, you'll get a 1. And then moving across, this is the mean magnitude with parallax and so on in this table. So it just tells you how they correlate with each other. This is just, so we have to import this in order to plot. It's just one of the Matplotlib libraries. I'm not going to go into much detail with it because it will be extensively explained next week. But I just wanted to show you how it views. So what we're plotting here is just a histogram. It's just a histogram of the star distances and no, the magnitudes and the number of stars, and then distributed by the magnitude. So if you look here, there's a higher number of G magnitudes around 15, because that would say that there's about 1,750, well, more than that, maybe 1,800, 900 stars in that category of G magnitude. And then you can see that the lower end of magnitudes has less number of stars, but you can plot anything in a histogram just to see how many of them are there. It's just that histograms are very useful for you to be able to see, and these are binned. When you say binned, that's a number of data points within a bin size. So you can set this number, whether it's 10, whether it's 100, whether it's 20. If you change this to a lower number, it will be more spread out because less numbers are binned within that number, that value. But like I said, it will be described and explained a bit better next week. So someone asked about hypothesis testing, and here's just a brief example of how this is done. So here we choose the bright stars, which is everything that has G magnitude less than 15. Okay, so firstly, this is the question. They're asking, do bright stars G less than 15 have different average proper motion, which is just called PMRA in the data frame, than faint stars, which they classify as the magnitude greater than 15. So we take the information given, which is magnitude less than 15 to be bright stars and faint stars to be magnitude greater than and equal to 15. So now we have two sets of data, we split them up. Then we use this stat test to test the variables against each other, the bright stars and the faint stars. So you'll get a p-value for t statistics. You'll get a t-stat value, and then you'll get a p-value from doing the stats test. If the p-value is less than 0.05, that means there's no statistical significance or difference in the average proper motion. And if the value is greater, so this is if it's smaller than 0.05, if it's greater, then there is a statistical difference. If not, then there's no statistical difference found. So as you can see for this specific data set, the t statistics is 0.26 and the p-value is 0.7, so no statistical differences are found. This is just the write-up of what I just explained, how two independent samples are tested, which is just this over there. The proper motion is just this over here, which is just a column in the data frame. The t statistic measures how different the groups are from each other, so the relation to them, and then the p-value tells us the probability of seeing such a difference just by chance. So here they're just again interpreting the results, because the results found here was greater than 0.05, it says that there's no significant difference. So if you're using your own data set and you know these values, let's say not astronomy, something else, and you set your p-value to be 0.1 or 0.7, this you can change according to what your data set is needed or how your data should relate, because it's not always the same for each variable and for the variable relating to each other. You can set that value. This is just, again, definitions that you can read up on what it means. Yeah, the lower the value, the more significant it is. The lower the p-value, sorry, the more significant it is. So in the real world, you can set your p-value to what you think is more realistic. If you think a realistic value is anything less than 0.1, then you can set it to that. Simple regression with Statsmodel. So you predict the magnitude using the distance, and then you perform a simple linear regression using the Statsmodel library, which we'll show you down here. And in this specific example, we're going to use the distances that's in parsecs, not in parallax, the one that we calculated above. So each line is just described. So the first line in this code is, so yeah, it just describes, okay, we're using the column that we created above, which is distance in parsecs. And then this SM add constant is just, it adds a column of ones to this X, which we creating a variable. And then this will now intercept or constant term of regression, and that allows the line to be shifted up and down the graph, which you can plot with the data that is coming out here. Then Y is just the data set that we choose, which is the mean magnitude from the data frame. So that's just one of the columns. You can, again, choose from your data, any X and any Y. Modeling, now you're taking Statsmodel, and this OLS stands for ordinary least squares. So there's different, there's various different methods of performing this. There will be a list of the different ones that you can use. For this example, we're just going to use the ordinary least squares, and that fits according to the least square. So it calculates the best fit line according to ordinary least square. You can do the, there's various different ones that you can do. I'm not going to get into how complicated it can get, but the stats model is very advanced, and there's lots of different models that you can use. And then printing model summary would give you this whole table. This whole table will give you coefficients for slopes and intercepts. It will give you the R squared value, which is just how well the line fits the data. So if you have a widespread data, then the R value is going to be much higher. If your data falls within a straight line, or whatever line you set, because you can have a straight line, you can have an exponential, you can have various lines that you fit into the data. And this R squared just tells you how well that line fits the data. Then you have the p-value, which we already spoke about, which is just like the statistical significance. And then it gives you errors, standard errors, confidence intervals, and various errors. So here you can see there's the R value, adjusted R squared value, the dependent variable that we set. We gave it the model of the ordinary least squared. Just gives you the date and time, the number of observations. So once we chose the data set, we checked how many observations they had, probability of the statistic, log likelihood. So it gives you a lot of different values that you can use for your outputs. And then these are the coefficients that I spoke about, and the error associated with them. This can be used to plot, which can also be shown next week. I can add this and plot it. You can make various plots for whatever paper you might be writing, or just to put in a presentation to say, okay, we did this test and we found that the likelihood of this happening is XYZ. So you get this whole table, which gives you all the information that you need with your statistical errors. Here's just a write-up of what they mean. So like I said, the coefficient is just the slope and intercept, so basically the gradient of the line, and the y-intercept. The slope can tell us how much the brightness changes as they move further away, because they are related to each other, so x and y values. R squared R squared is usually between 0 and 1, and that can explain to us how the brightness changes according to distance. But like I said, with any data that you use, it will tell you the relation between your two quantities or parameters. Closer to 1 means better fit. So if you have a 0.9 R squared value, means that if this is your line, your data lies very close to your line. Standard error just gives you the error within the coefficient. So if you have data points around a line, they take the error in which that points would fall on the line, basically. Then here's again technical terms that you can read up on. As I said, ordinary least square is not the only model you can use. There's various other models that you can use. And then you have some homework questions, which is just data cleaning and all the things that was explained up there. You'll do it with the same data, but with different values. Here is some extra information on a link, but additional resources can also be sent on Slack according to what you want or need. Then we have this notebook, which is just more advanced. It's way more advanced than the basics. So here it gives you descriptive statistics, or what the standard deviation or how it's calculated, the skewness, and I'm not going to go through the whole notebook because you'll be going through it yourself. But it has different plots and all these more advanced than the previous one. You can ask questions about this in the Slack channel once you get past all of these and then go through this. If you have any questions, you're more than welcome to ask. And then we have this data set, which is just created from the Numpy or Pandas Jupyter notebook. I'll answer any questions of the third notebook, well, the first and second and third notebooks before I continue. Okay, so I have to stop sharing in order to see the questions. Okay. Other material. So just pose the question for other material. I think I answered that in the Slack channel. Okay. Okay, someone answered that question. I usually import them all at the top. So even if I get lower in my code and I need to import, I'd put it at the top so that I import all the libraries that I need for the specific notebook. But you can add them at the specific time that you need them. You don't specifically have to add them right at the top. Oh, I missed the question somewhere. I'm not sure where I missed it, but okay. Is it possible to view the whole data set? So yeah, it just depends on how many rows you want to see. Sometimes there's too many rows and columns, and if you want to load them in a notebook, it's not really possible because it will be too much to load at one time and to display. So it's not always advisable. You could choose a specific column or a specific row and column to print or to display, and that makes more sense than displaying everything all at once.
There was a hand up from Jayton. I don't know if they'd still like to ask their question.
Yes, I had one question. Suppose I have a star data and there are many columns, and in some columns there is none, like there is no data, but I can using some formulas find that data. Suppose I have a temperature data, and in some what we can say some row and column there is no temperature data, but I have luminosity data, and using formulas I can predict that temperature of the certain star, and there are many such data. So how can I replace them instead of making a new column of predict temperature?
Okay, so you can call the specific column and edit the column. So you can add data to a specific column that has no data.
Uh,
Just pose the question, then I can type out what command you'll use, but you don't have to create a new column if the column already exists and you just want to add to that column. So once you've done your calculation, you can add to that specific column without creating a new column. So if you put it in
but
Slack, I can just put the command there.
okay,
So basically it's overwriting the column that has no data in.
yes, but what if there are many such columns and I don't know about doing that? How I can replace
So
within
you
one command?
so you'll first have to find out how many columns they are. So print the names of the columns and you can see what is in this data frame. So if there's, let's say, distance, and most of the time the distance would only be one column unless they are in different like distance in parallax, distance in parsecs, then it would be different values. But most of the time there won't be a duplicate of the same values, if that makes sense.
Okay, ma'am. Thank you.
Pleasure.
Okay, we've got a question. Could you provide a brief overview of hypothesis testing using various Python libraries or statistical techniques, along with a justification for each approach?
Okay, let me see if I can open something and show you. So you want to know the justification of it. Okay. Can I send it to you in Slack? Can you post it in Slack and I can send you all the details and also where to find all the information?
So yes, we suggest posting that question maybe in the week 2 Slack.
Yeah, because that's because it obviously works with different data differently. So the justification would work differently for each data set, but I can send you a link to how this works, and also it will show you in each library. When you get the outputs, it will tell you how reliable the output is. So if the output is like 10% reliable, I don't think you should take that the answer as concrete and rather work on it more. Remember, coding gives us answers according to what we give it. So if we give data sets that's all jumbled up and has no correlation, then the output will tell us that, okay, no, the correlation is bad or the output is bad. So then you maybe have to filter it a bit more, or edit it a bit more, do some calculations to get more specific answers, and then run the test, if that makes sense.
Okay, I'm going to add that question to the week 2 statistical analysis, and then Narusha, if you could answer that, provide the links there, that would be great.
Okay, I'll do that.
Okay, cool. There's another question. In upcoming days, will we be working on image data or only with tabulate data?
So for this week, there's tabulated data. There is in future weeks image data, I think not next week. Although we could add in next week. I don't think there's in next week. But I know in future weeks there is some image data. but not specifically this week.
Okay. Could we get the materials of your presentation, please?
Yes, I can share that.
Okay. And I guess that will be shared after this on the Slack channel?
Yep.
Okay. How to do the time series feature predictions. The code you show is to predict a certain value, but how to detect the time at which some threshold is reached from the time series data.
So
Second
if you go through all the notebooks, it should be in there. So once you've gone, I think through the advanced, it will be in there. If you still don't understand, and then just pose the question and then we can answer it, because that is definitely covered. And then it says, I guess you're having a different Slack channel of bricks than I've joined. Can someone share the link? It's supposed to be the same Slack channel. Let me just.
There is a separate bricks, but I think maybe get in touch with Lebo about that, and he can assist.
Yeah.
So the person who sent out the emails yesterday, if you reply to him, he should be able to assist, unless Lebo is in the room and can assist now. Is he here? No. Okay. So maybe get in touch with Lebo.
No, Sally, I am actually here.
Okay, great.
I'll send the link in the group in the.
Okay. Thanks, Lebo.
Okay, I see you sent a screenshot. If you go to add channels and browse channels, you'll be able to find the channel that we're specifically talking about. So the screenshot that you've showed, just go to browse channels. No, you're going to have to go to add channels and then go to browse channels and then try to add it from there. If you try that, then we could maybe assist before ending the meeting. Because from the screenshot, I see you haven't joined the other channels either.
And then there's just a question. If possible, please highlight on missing value imputation techniques in the current context.
Okay, so in that specific data set, if you look at an observation and there's, let's say, 10,000 stars, but not for all the stars did they calculate magnitude or distance, then there would be a missing value, so a NaN value. So that is specifically from observation. And you can't exactly just put in a random value. But if you have distance in parallax and you calculated all the distances in parsec and then there's a missing value, then you can still calculate it and then replace it. I will send out the command in how you can replace a specific value. So you call the specific row that you have this missing value. So it's obviously for a specific star that you have a missing parsec distance value, but that means you have to have the parallax distance in order to convert it into parsec. So in order to put in missing values, you have to have the required data beforehand. You can't fill in missing blank spots for observed data, because that means during the observation that data was not recorded. So usually we would take out that star, that specific star. So we'll take out, that's why we did the filtering. So we'll say all the stars that have negative distance, for example, that means that that was incorrect, or we ignore those stars.
Okay, there's a question. If we want to discuss other approaches, other concepts, other techniques related to astronomy and machine learning, but not things that are already in the material you've provided, who to connect to and how?
You can put it in the Slack channel. We all have access to the Slack channel. And we can have a discussion there. And that goes for every other question. If you have questions with regards to the homework questions, it would be great if you pose your question in the Slack channel and everyone can contribute and it could become a whole discussion. That would be helpful for everybody. So I don't think you should connect to a specific person, but in general, put it out in the Slack channel so that everybody can have access to it, because it could be helpful for other participants as well. So just put it in the Slack channel. I think we can create, maybe Sally, we should create a general channel so that if it's not related to that specific week, they can put it in the general channel and then have a discussion over there.
Okay. There is a channel, Allbrook's Data Analytics Program. So that is our main channel. But I will make a general discussions channel now. Let's just do, I'll quickly make a general discussion.
Yeah, and then everyone should feel free to comment. If you have additional questions to a specific question, put it in there. If you want to answer a question, you're more than welcome to do so. And just start the discussion.
Okay, there is a general discussions channel now. And okay, so there's just one another question here. If it is possible to calculate a missing value from another column data, doesn't that mean the column with missing data are redundant entirely? So you can see that question, second last comment.
So you're saying so what are you asking, is the missing data redundant entirely? Because if you have a column and you can calculate where the missing data is, it doesn't make that entire column redundant, because now you can fill in the missing blanks or fill in the missing values. Does that answer your question?
Perhaps above, if that you can comment in the chat and or on the Slack if you want to hear more. Then yeah, and then we've got a question from Bavar. Can we ask about a specific or lessons which has passed, for example, the past week in the Slack?
Yes, so there's going to be a Slack channel for each week. And the best would be to ask the question within that week's channel. So if it was week one's questions, you still more than welcome to pose questions in week one, because it will still be open throughout the course. Although for some reason I can't join. I was kicked out of week one. Sally, do you still have access to week one?
It is there, but it's set as an external connection. Maybe Lebo, can you look at week one and why it's set as an external connection?
Okay, because I used to be part of it, but now it seems I'm kicked out of it.
Yeah, sure. I'll check it out. I'll check it out just now.
Okay.
Apologies everyone for that. We will check and look into the problem.
Does everyone know how to connect to the additional channels? If one person can just indicate if they don't know, then I can do a quick rundown of how to do that. I'll just share my screen and show you.
I think it would be worth doing it anyway, yeah.
Okay, let me do that quickly.
And I think it's worth noting that you don't automatically join channels. You'll need to do this on a weekly basis so that you can join the week's channel. you'll need to do this process that Narusha will show now.
Okay, so let me just share my screen. So for example, this is what you would see. Some people only have introduction and Allbricks data analytics program. So you'll go down. So I already joined these channels, but you'll go to where it says add channel. You'll click on add channel, go to browse. So create a new channel. That's not where you're going to go. You're going to go to browse channels. Then it will bring up all the channels that is available. So we have the general one, which you go. So here I already joined this. So it says joined and you can leave. Here I have not joined the general discussion. So I'll go to join and then I'll be part of this channel. So for every channel that you want to join, you can just go to it and join it or leave it. And then when you go back, all the channels would show up here. So as I was saying earlier, you'll go to week 2 and pose any questions in week 2, or you'll go to week 1, pose any questions there. There's a job advertisement opportunity. Anyone that wants to join that, people will post various opportunities and job registry there. But all the information would be here. This is the pre-course orientation. Yeah, so all you do is go to add channel, browse channels, and then if you scroll to the right, it will give you the join or leave option on the right hand side. Okay, so does anyone have any other questions?
There's another question, just the last one.
Okay, just another.
Just another query, how researcher worked with object detection in astronomy worked till now, and which type of problems have they faced, and in which way could one approach to solve this?
So in the astronomy world, there's been many problems, and they've been solved in various ways. Specifically, I think the most common problem that we can speak about is interference. So when they're detecting anything, data needs to be cleaned because there's interference from anything that could go in front of the telescope. So if it's a ground-based telescope, we firstly have our atmosphere. We have various other objects in the sky that we don't want to necessarily study. So we first have to get rid of all of that before we can actually study our objects. Specifically in South Africa, many people work with radio data currently, and radio interference has been a big study at this in the past few years. Something they found that was interfering with radio data was a frequency from a cell phone. So they had to go to the data and remove all the detected frequencies within that cell phone range. So that's how you mitigate any problems. But you first have to find out what the problem is, where it originates from, and then basically clean out or filter out that information. It would be nice if we could have clear skies all the time, because that would remove many errors, as they're saying in the chat. But it's just not possible. And because we have many things that contribute, like pollution and etc. And even just debris that's out there, that would also show up on your data sets, but that needs to get cleaned out before you can work with the data. And that's just the one of the problems that we have in astronomy. There's many other. And another one would be a reason why we model galaxies, for example, is we don't get clear imaging of a galaxy. So if it's far out, the imaging would be a bit blurry. So we try to model it as best as we can to get as much science out of it. So we model a specific galaxy maybe in increments to get the best image of the galaxy in order to do science with it. So yeah, like I said, you first have to find the problem, find where the problem comes from, and then address the problem. So there's many ways also that people can approach the same problem to solve it. And that's what makes it really interesting in astronomy, is because you can compare your results with someone else's results that approached it in a different way. And you may or may not get the exact same answer, or you may get something different, and then you can explore the reasons why and what affects your outcome. Okay, it says, I'm currently conducting research on EXO, okay, using machine learning techniques, particularly. Okay, so with data sets and requesting, so this is just one of the questions that was posed in the message box, is how to access data that is restricted or private. Sometimes it can be very difficult. I'm not going to lie and say it's easy. Collaborations is the easiest way to get access to data. So trying to form collaboration with people, PIs, people that have access to the data, to work with them on whatever specific project you're working on, and then work with them on their project and propose this. I think the best way is not to be afraid of asking these questions. Try not to limit yourself. And so you'll go to a data set, you'll search a bit about it. Sometimes there's papers on a specific topic, but using that data set. And then you'll try to find who is the PI or who's working on projects with that data set and approach them directly. Especially if it's not publicly available, you can ask them and they may or may not agree. But that's the easiest way. Sally, I don't know if there's another way to request access besides contacting them directly. I'm not entirely sure.
I'm not sure myself. Someone suggested cold mail.
I mean, it's not cold mailing. You approaching someone to possibly work with them. You're not saying, "Oh, give me your data." You're proposing a collaboration. And if I'm honest, astronomers are very, very open to collaborations. Many of them would be happy to work with you. Pleasure. Is there any other questions? So, yeah. So I see someone saying that they work with theoretical and how would data analysis work or help them. So even in theoretical, I'm assuming theoretical astronomy, there is lots of predictions that are made, lots of assumptions that you want to test, and all the packages and tools that I've described earlier is helpful for these and differential geometries. So especially with machine learning, if you have a theory and you want to test this theory and just create random data sets to test it with, you can create a database, a theoretical database. It doesn't have to be observed. And then from there, you can separate your data. As I said earlier, you'll have a testing data set, you'll have a, what do you call this? Training data set. And so, yeah, so even though you're in a theoretical background, you can still use the skills learned here for that specific research. Sally, do you want to take the last question?
This is quantum
Yeah.
logic. That's a bit, yeah.
I don't know, but I can find out. Let's
Yeah.
put it that way.
Yes.
So I don't know working from Boolean logic to quantum logic, but I can find out the information there. And then I see someone says, I'm very young in the field. Problem is with communication skills. Yeah, the only thing is to start somewhere. There is no fast tracking that. You can train yourself. There is lots of resources actually to help develop communication skills and scientific communication skills, but also just speaking to people, networking, going to conferences. And like I said, start out by just sending one email and then you'll gain experience from there. You have to start somewhere. Okay. Someone is asking, let's say I want to gather some observational data. Do I open an Excel spreadsheet and start recording over a period of time and then start analysis? So usually with observational data, it comes in a CSV file, which is basically a spreadsheet as well. And you start analysis from there. When you say start recording over a period of time, are you wanting to do the observations yourself? So do you want to? Okay, so then you'll have to get in contact with a telescope operator and learn more about that. So that would be the core basics of the actual telescope operations and collecting data. I don't think, however, it is open an Excel spreadsheet and start recording data. I don't have the more technical details. I don't know, Sally, if you have, but that would be reaching out to someone that's in telescope operations and observations. I can get more information for you on that, but I myself don't know. Okay, how can I know that certain data set will help me? Like for an astronomical system, there is a lot of data in Vizier. How I know which one? So that is all part of learning. You need to first think about what is the data you need for the research you're trying to do. So, for example, if you need to get magnitudes for whatever purpose you need it, you will have to find out what data set contains magnitudes, and not only what data set contains magnitudes, but what data set observes the field in which you're looking. So if you're looking at a specific region, you'll have to find out what telescope observed that region. And then if they have magnitudes in that data set. Vizier is a good online helpful data set because you can actually search it there. So first you'll find or describe what you need. So if you're saying I need magnitudes in this region, you go to the data set and then try to find it from there. But I know that there's a lot of data there. To filter through, you need to be very specific in what you need. Don't just go there and be like, I'm looking for all data of specific region. You're going to get lots and lots and lots. So rather narrow it down to what type of data you're looking for. Okay. Sally, did I miss anything?
No, I think you've got everything. But if we have missed out anything, of course, please feel free to, our apologies, first of all, if we have missed anything out, but please feel free to post it to the Slack channel and we'll take our time and get to it. Oh, there's just one more question now. Any suggestions for master's students starting out in physics?
So what do you mean with suggestions? You looking for specific courses, or are you looking for a university? Because there's different universities that have different opportunities, and there's lots of different physics opportunities. Since you're doing masters, I'm sure you want to major in something specific. Is it nuclear physics? What kind of physics is it? And are you asking for suggestions with regards to university, bursaries? What exactly would you like suggestions of? To get ultimately into research. So you need to, within research, there's many different specializations. So if you like nuclear physics, then you have to go into nuclear physics and see what specific aspect of it you'd like to research in. Then there's material science, nanoscience. There's many opportunities in each one, very differently. Even renewable resources falls under physics. So that's why I'm saying you need to be very specific of what kind of physics you want to go into. There is a channel that's opportunities. You could post that question and then I could send some links, but it would be more helpful if you can say what exactly you looking into, because physics is very, very broad and it's difficult to say exactly what to do because there's research in all aspects. Actually, I want to do research in gravitational waves astronomy in future. Okay, so gravitational waves, there's various universities that offer this. Post it in that channel and I can send you some links. I think there's some universities that start in September. Correct me if I'm wrong, Sally, but there is some universities that start in September that you could email the professors there, your potential supervisors, ask them about the projects that they have, and how to get into that.
I mean, it depends on. So this is. It depends on if it's masters, then or yeah, it's worth just reaching out and seeing when they start, and if you can start whenever. In South Africa, it's typically, for example, with masters, maybe not so much, but with maybe earlier years, it's typically started at the beginning of the year.
Yeah.
It's just the way that South Africa works. But masters I have known to start in South Africa at least later in the year as well. So it's just worth reaching out.
Yeah, definitely. Okay, I see someone says they have access to a telescope remotely. They want to gather observational data. Okay, so post this in the Slack channel. I'll try to get information on that, but I've never done actual observations myself, and how that would work, and create a app from the data. Okay, that seems really cool, but I can't help you directly with that information. Okay. I think I covered all the questions. I'm not sure. Okay, I see you saying something about masters and they are very advanced. So with masters, you can still do coursework and check out and still learn, be in the learning phase before you do the advanced project. But yeah, reach out to the professor directly and you could attend some coursework before doing the actual research project. Are there any other questions?